UGC NET Electronic Science June 2025 question paper solutions part 6 question number 126 to question number 150. Question number 126. What is a unit of electric flux density? Electric flux density D is equal to Coulomb per meter square. Units are Coulomb per meter square. For electric field intensity E, units are volt per meter. The units for magnetic field intensity H is ampere per meter. For magnetic flux density Weber by meter square or Tesla. For current density ampere per meter square. For permittivity farad per meter. For permeability mu Henry per meter. So units for electric flux density is Coulomb per meter square. Question number 127. Arrange the following class of power amplifiers in the order of increasing conduction angle. The conduction angle is maximum for class A power amplifiers, whereas conduction angle is minimum for class D power amplifiers. For class A power amplifier, conduction angle is 360. For class AB power amplifier, conduction angle lies between 360 to 180. For class B power amplifier, conduction angle is 180 degrees. For class C power amplifier, conduction angle is less than 180 degrees. For class D power amplifier, conduction angle is 90 degrees. So here, class A maximum and class D is minimum. Class D is minimum, that is E, class C, B, class B, A, class AB, C, class A, it is D. The correct answer is E, B, A, C, D. Option 3. Question number 128. The characteristic impedance of uniform plane wave in free space is. So characteristic impedance is under root of mu naught by epsilon naught. Mu naught value is 4 pi into 10 power minus 7 Henry per meter. Epsilon naught value is 8.854 into 10 power minus 12 farad per meter. Mu naught by epsilon naught is 120 pi or 377 ohms. Characteristic impedance of uniform plane wave in free space is 120 pi. Question number 129. In a given block diagram of PLL circuit, the input frequency is 40 MHz. What is the value of output frequency F out when PLL is operating in the lock state? In this PLL, PFD, phase or frequency detector is a circuit that compares a reference clock signal with a feedback signal from a voltage controlled oscillator. Here, input frequency is output frequency divided by 4. Output frequency is 4 times of input frequency. Given input frequency is 40 MHz. Therefore, output frequency is 4 times of input frequency. 4 into 40 MHz. Output frequency is 160 MHz. Correct answer is option 4. Question number 130. What is the correct option in terms of transmission lines? Characteristic impedance Z0 is equal to R plus J omega L by G plus J omega C. Statement A is correct. In statement C, it is reverse. C is in the numerator, so statement C is incorrect. Phase constant beta is equal to omega root LC. Statement B is correct. Statement D, phase constant is incorrect. Phase velocity Vp is equal to 1 by root LC. Statement E is correct. Therefore, correct answer is option 3, A, B, E only. Next question. Arrange the following in sequence of steps for writing state equation. So the sequence of steps for writing state equation is: step 1, choose a normal tree for the network. Step 2, take either voltages or charges across capacitor and currents or fluxes through the inductor. Step 3, write KVL, KCL and branch voltage current relations. Step E, eliminate all non-state variables of the network. Step D, rearrange the vector matrix differential equation for state variable representations. So from the options, the correct answer is statement A is step 1. Take either voltages or charges across the capacitor. Step 2. Write independent KVL, KCL and branch voltage current relations. Step 3. Eliminate all non-state variables of a network. Step 4. Rearrange the vector matrix differential equation for state variable representations. Step 5. Correct sequence is A, B, C, E, D. Correct answer is option 3. Question number 132. Arrange the following components in the order they appear in negative feedback control system. The block diagram of negative feedback control system is given. This closed loop control system output is fed back to the input. So control action dependent on desired output. In these systems, the error detector produces an error signal which is the difference between input and the feedback signal. The closed loop control systems are also called as automatic control systems. So here the first one is set point. Set point, then error detector, controller, controller output, plant output. Therefore correct answer is C, A, E, D, B. Option 2. Question number 133. Divergence theorem. Closed surface integral of d bar dot ds bar is equal to open volume integral of d bar del dot a dv. So A matches to 2. Stokes theorem. Closed line integral of a bar dot dl bar is equal to open surface integral of del cross a ds. B matches to 3. Gauss law. Del dot d is equal to rho v, or surface integral of d bar dot ts bar is equal to volume integral of rho v dv, that is equal to charge enclosed. This is closed surface integral. So C matches to 1. Poisson equation is del square v is equal to minus rho v by epsilon. Therefore correct answer is A2, B3, C1, D4. Option 1. Question number 134. Which of the following materials will form p-type semiconductor on doping to an intrinsic semiconductor? This intrinsic semiconductor or pure semiconductor. The correct answer is boron. Boron is third A group element. So p-type semiconductor, when trivalent impurity is doped to an intrinsic semiconductor, then p-type semiconductor is formed. Here majority carriers are holes and minority carriers are electrons. Third A group elements are boron, aluminum, gallium, indium, thallium. Correct answer is boron. Option 3. Question number 135. Arrange the following materials in descending order of their Hall effect coefficient Kh. The Hall effect coefficient is negative for metals, positive for p-type semiconductors, negative for n-type semiconductors, and 0 for insulators. Metals have higher carrier concentration, resulting in small and negative Hall coefficient. Insulators have high energy gap and virtually no free charge carriers, leading to 0 Hall coefficients. Whereas semiconductors with intermediate carrier concentration exhibit Hall coefficient that is directly related to the sign and magnitude of their dominant charge carriers, that is holes and electrons. A material which is dominated by positive charge carriers such as holes in semiconductors. RH is greater than 0, RH is less than 0, negative for electrons in metals and semiconductors. The sequence of the decreasing sequence of Hall coefficient KH is tellurium is having highest Hall coefficient in the given list, and it is minimum for metal, that is iron. So correct answer is tellurium greater than arsenic, greater than silicon, greater than iron. That is D greater than A, greater than C, greater than B. Correct answer is option 2. Question number 136. The switching characteristics of a power MOSFET is influenced to a large extent by. The switching characteristics of power MOSFET mainly depends on internal capacitances and impedance of a gate drive circuit, because during switching the gate capacitance must be charged and discharged quickly, and gate drive impedance directly controls the speed. Correct answer is option 1. The switching characteristics of power MOSFET are influenced to a large extent by internal capacitances and internal impedance of gate drive circuit. Question number 137. Suppose the G0 diode in the figure is ideal and has a breakdown voltage of 10 volts. What is the maximum current through the diode? Current maximum is input voltage Vi maximum minus Zener voltage by source resistance Rs. Here maximum input voltage is 40, Zener voltage is 10, and source resistance is 820. The maximum current is 36.5853 milliampere. Correct answer is option 2. Question number 138. For the given network, what is the state equation? To find the state equation, write KCL at node A. KCL at node A is sum of entering currents is equal to sum of leaving currents. Current I is equal to IC plus IL. So from this, dVc by dt is equal to 1 by C into I minus 1 by C IL. Similarly, write KVL in this loop. D voltage Vc is equal to voltage across the inductor, voltage drop across the resistor. That is L dIL by dt plus IL into R is equal to Vc. So from this, dIL by dt is equal to 1 by C Vc minus R by L IL. So based on these two equations, this equation and this equation, the state equation is d by dt Vc IL is equal to 0 minus 1 by C 1 by L minus R by L Vc into Vc IL, these are the variables, plus 1 by C 0 into I. The correct answer is option 1. Question number 139. The microcontroller 8051 has. So this 8051 process data in 8 bits chunks. It has registers, ALU, data bus are all 8-bit wide, and it uses hardware architecture. In hardware architecture, it uses separate memory space for program code and data. Program memory stores instructions. Data memory stores variable and runtime data. Correct answer is option 3. Microcontroller 8051 has 8-bit hardware architecture. Let us see difference between von Neumann architecture and Harvard architecture. In von Neumann architecture, the codes and data in the same memory, whereas in Harvard architecture, the codes and data in separate memory, which is relatively faster. Uses separate buses in Harvard architecture, whereas using only one channel or bus in the von Neumann architecture. Correct answer option 3. Question number 140. In the following statements, 5 different statements are given. Choose the correct answer from the options given below. 8051 is 8-bit microcontroller. Statement A is correct. 8051 is 8-bit microcontroller with 4K RAM, ROM, 4K read-only memory, 128-bit RAM, 32 IO lines, 2 timers, 5 interrupts, serial communication, and multiple addressing modes widely used in embedded systems. Statement A is correct. 8051 has overflow flag. Statement B is correct. 8051 has 5 interrupts. So the program status word in 8051, program status word contains overflow flag, and 8051 has 5 interrupts, that is 2 external interrupts, 2 timer interrupts, and 1 serial interrupts. 8051 has also indexed addressing mode. Statement D is correct. Statement E, CJNE is an instruction of 8051 microcontroller. CJNE, compare and jump if not equal. It is an instruction of 8051 microcontroller. All the statements are correct. The correct answer is option 3. Let us see important points here. CJNE, branch loop instruction of 8051 microcontroller. Program status word contains overflow flag. It is having 8-bit data bus. There are 5 interrupts, and it is having indexed addressing mode. Addressing mode is indexed. All statements are correct. Question number 141. A constant voltage scaling with scaling factor S is equal to 0.7 is used to scale a MOSFET. The speed of scaled MOSFET will increase by nearly dash times. Here in the question, constant voltage scaling is given. Voltage scaling speed increases as 1 by S. That is 1 by S. The scaling factor given in the question is 0.7. 1 by 0.7 is 1.428. Approximate answer is 1.43. Correct answer is option 2. Next question. In constant field scaling with a scaling factor of S is equal to 0.7, the power density of scaled device is dash times of power density of unscaled device. So constant field scaling, they have mentioned constant field scaling. Power density is constant irrespective of scaling factor. Therefore, correct answer is option 1. The power density of scaled device is same as power density of unscaled device. Question number 143. One of the short channel effects referred to as drain induced barrier lowering results into. The drain induced barrier lowering is a short channel effect in MOSFET at high VDS depletion region from drain extends towards the source. This reduces the source channel barrier, making it easier for carriers to flow. As a result, threshold voltage decreases when VDS increases. Because of this short channel effect, due to drain induced barrier lowering, decrease in threshold voltage with increase in VDS takes place. Correct answer is option 3. Question number 144. What will be the change in power dissipation of a MOSFET when scaled by the constant voltage scaling? Again here constant voltage scaling with scaling factor 0.7, power dissipation is mentioned. In this case, power scaled to power unscaled is 1 by S, that is 1 by 0.7, its value is 1.43. Correct answer is option 1. 1.43 times increase in power dissipation after scaling. Question number 145. In constant field scaling with scaling factor of 0.7, the on current in scaled device is dash times of on current in the unscaled device. The on current in scaled device is S times of on current in the unscaled device. Here scaling factor is 0.7 as given in the question. Correct answer option 2. Question number 146. The detector used in optical detector at receiver of optical communication link is. Optical detectors are devices that converts an incoming optical signal into electrical signal. Different optical detectors are PIN photodetector, avalanche photodetectors, phototransistors, photomultiplier tubes. So from the options, LEDs and lasers are light sources, optical fiber communication. So xenodiode is voltage regulator. Therefore, correct for answer is avalanche photodiode, which is an optical detector. Question number 147. The approximate height of geo orbit from Earth surface is. Geostationary satellite is a satellite that appears to be stationary relative to particular place on the Earth surface, located at a height of 35,786 kilometers in geostationary orbit. So this geostationary orbit is circular shape orbit with zero inclination with respect to the equator. Time period is 23 hours 56 minutes 4.1 seconds. The correct answer is option 4. 35,800 kilometers. Question number 148. A 4G network promises speed up to dash in cell phone and up to dash in local Wi-Fi. So for mobile it is 100 Mbps. For local Wi-Fi it is 1 Gbps. According to International Telecommunication Union Radio Communications, 4G mobile speed is 100 Mbps and for 4G local it is up to 1 Gbps. Question number 149. Optical fiber has core refractive index of 1.45. Refractive index of core is 1.45 and refractive index of cladding is 1.4. Then what is numerical aperture? Numerical aperture is Na is equal to under root of Nc square minus N clad square. This is a formula to obtain numerical aperture of a optical fiber. So from this, substitute the value of Nc is 1.45 square minus 1.4 square. So its value is under root of 0.1425, that is 0.37749. Correct answer is option 1. Question number 150. If the cell coverage radius is r and the frequency reuse constant is k, the minimum frequency reuse distance d is given by. The formula for minimum frequency reuse distance d is equal to under root of 3k into r, where r is cell coverage radius, k is frequency reuse constant. Therefore correct answer is option 3.